right. Good morning, how's everybody doing?
Good.
BMC Hinnant, Bravo Company. I want to talk to you today about offshore petroleum discharge system, or OPDS. Now, OPDS, when it was out there, it was pretty cool stuff. It was developed, around the 1970s and actually put on the street around mid-1980s. CB1 is a primary deployer of OPDS, but it is a part of not our MPF requirement. So when you're looking at the MPF manning documents, you need to look at the salt follow-on echelon manning for this. All right. It requires a great deal of manpower to deploy the system. Several different units to come together to deploy the system. It's not really practiced on the East Coast or the West Coast in the full aspect of it because there's a lot of environmental concerns with the system. This is a wartime, right on the Marines' heels type deployment. Right after your salt over. Okay. It can operate in both environments, but the primary mission for OPDS is to support the Marines' push inland right off the bat, just like ABLATS would be. But ABLATS is an MPF mission. And some assault follow-up. Right. Now, this is the requirement within 48 hours of arrival. The tanker should be ready to deploy its OPDS to the beach. Now, the ranges here, it can do one product 4 miles or 2 products 2 miles from the same ship. Okay? It's supposed to arrive on station and go into a 4-point moor right off the bat and start streaming hose straight from the ship all the way to the beach. Okay? And how that's going to happen is once they arrive on station, the ship is loaded out with all the gear, all the boats, the BTU, beach termination unit, all the support equipment that has to do with deploying OPDS. And that stuff's going to get offloaded just like you would if you were doing an MPF plant. And the ship arrives on station, start offloading ladders and things of that nature. But the ship has to go to a 4-point moor first. And to do that, you're going to have to offload the 3 UBs, which are OPDS utility boats, which are nothing but modified Mike 6s with A-frames on them. They kind of look very similar to the old NL working tugs with that stationary A-frame on there. And they have the same type deck winch on the deck too, but it's a modified Mike 6. So it's a little bit skinnier, a little bit higher out of the water. They also have a lay repair barge, which is kind of the meat and potatoes of deploying the conduit, because that's what takes the hose up out of the water and runs at the length of the craft to be able to make connections with the couplings, with the fittings. And I'll show you some of that here later. But the first thing it does is go to a 4-point moor and starts running conduit straight in. Now there's a beach party team requirement that is not deployed from the ship. That is still going to be a part of the beach party team with the assault element that goes ashore from the amphibians. Right? That is the beach party team for BMU and the dozer deck. And we must have at least 1 LARC to do this operation from the beach. Those assets will already be there. All right, so you don't have to worry about deploying those. They're all part of the solid. So within that 48 hours, we're doing that straight to the beach. I got to have a LARC on the beach, all right, to receive some equipment that I'm going to be deploying from the ship. You got 3 OUB boats. You have 1 lay repair barge, and you have 1 dive boat. The dive boat is not necessarily for the 4-point moor. The dive boat is the requirement after 7 days, and we'll get into that here in a minute. Now, the BTUs have to go to the beach. So you ask yourself, well, how the heck this thing is going to go to the beach? This thing's 5,000 pounds. Okay? Well, it floats. It has a ballast system on it, and it floats. So the ship's crane will offload that BTU into the water after it takes its anchors off, because it's heavier than the crane can lift up. And they'll put that thing in the water, and an OUB boat will tow that thing just outside the surf zone. Okay? With a short length tow. And it has its own tow line and capabilities to tow. So once it gets to the surf zone, then we'll call a LARC out, and the LARC will finish towing that thing right up onto the beach. And that's why it's important to have the beach party team there. All right. They're going to grab the anchors off the OUB and take them ashore too, along with the BIU crew, or excuse me, the BTU crew. I just did ABLAT, so I'm still doing ABLAT acronyms. But the BTU crew is the size of 15 people. We'll get into those crew sizes here in a little bit. It takes quite a bit of people to operate the BTU ashore. Now the other end, the customer end, will be assisting with this also. That could be elements of the assault or amphibious assault fuels guys from the USMC or the Army bulk fuels companies to be able to assist this stuff. And those guys will be deployed inland. They're not coming from the ship or anything like that. They're not coming from the MPF ship. These guys are already flown in with advanced parties and stuff like that. All right. So once I pass the BTU to the lark, it's going to tow it up on the beach. Then the bulldozer is going to take it over from there and drag it up 100 feet past the high water mark. Okay? 100 foot past the high water mark. Then I'm going to anchor it with a 100-foot line, which will be wire rope, with a 1,500-pound single anchor. And it's a Danforth, just like we use for the BIU, but it's greatly larger. That's why you need a lot of support on the beach to move the stuff around. Either the dozer, if the fuels company has a crane available, it's like a 60-ton crane, we can do it with that, or we can just drag it on the beach with a dozer. Now to bury that anchor, it needs to be an 8-foot by 8-foot by 4-foot deep hole. And then we'll drop that anchor in there and cover it up, and then the BTU is anchored to the beach. Now while this is happening, since we're doing a 4-point moor, like I said, we can do one conduit for 4 miles or 2 miles. There you go. So while this is happening, those UBs that are not involved in the surf zone are not involved anymore with the BTU, they're going ahead and they're hooking up to the bitter end of that OPDS conduit, and they're going ahead and reeling that stuff off the ship, off the discharge side. All right. When you go into a 4-point moor, the ship needs to be bow into the current, into the 4-point moor. And when the OUBs deploy those 4-point moor anchors, they're actually buoys that sit on the surface where the anchors are that are quick disconnect in case the ship has to get underway in emergency, and also to facilitate follow-on tankers that are going to be using the 7-day system that we'll get into in a minute. Good to go? All right. And after the conduits ran to the beach, there is a couple delivery methods, and we'll get into those here in a little bit. Anyway, after that's done, that's their 48-hour requirement. And the 7-day requirement is deploying that thing you heard called the SOM, right? Single ankle leg moor. Y'all heard that before? And that is a big evolution, huge evolution. That involves not only the ship, the lay repair bars, the OUBs, but it involves the underwater construction team divers to be able to deploy the system. And that's what they're going to do after, and you can still run the same type conduit, either 2 miles or 4 miles, whichever one you want to do, whichever the fuel company ashore requires. But the deployment initially is straight from the ship. Everybody cool with that? And after 7 days, while they're in the 4-point moor, they're going to deploy that SOM, sink the SOM, hook up conduit from the ship down to the SOM base, hook up the conduit from the BTU to the SOM base conduit, and then that buoy on top is just going to be a mooring buoy for follow-on tankers. And we'll get into the nuts and bolts of that here in a little bit. That's what your 4-point moor is going to look like offshore. Running conduit straight from the ship all the way up to the BTU. And the BTU is beach termination unit again. And 100 feet above the high water line. And this is the SOM deployment, where they're actually going to deploy a SOM and a SOM base and control sink the SOM base, run conduit up to a pigtail off the ship. This is the SOM single ankle leg moor that's going to act as a mooring buoy. And you can see they have a mooring hawser here from the bull nose of the ship all the way out to the buoy. And then your pigtail hose from the conduit connect from the BTU conduit underwater. And that's more long-term system. And depending on what the seas and weather conditions are, is how you're going to deploy that. Yes, sir.
Regarding the conduit, does that get anchored to the sea floor in some capacity, or is it sufficiently negatively buoyant that when the fuel is being pumped through, that it stays down? Because there's a big density difference between seawater and fuel.
That's a good question. That's involved with how you're going to deploy it based on the sea conditions. But eventually, like I was saying, it will the underwater construction team, because it's going to be a long-term system, we're talking about 48 hours to 2 years. So eventually, once the evolution is complete, UTC is going to have to go back under along that pipeline and actually anchor that stuff to the seafloor.
But even on the 48-hour setup there, you have the conduit going to the seafloor. So is that getting anchored temporarily in some capacity?
No, sir, because they're going to be deploying the SOM pretty short.
So is it sufficiently negatively buoyant to stay down?
Absolutely.
Okay.
You know, it depends on the bottom. If we have a muddy, sandy bottom, it'll probably be better, and it depends on the currents at that level also. You know, and what's affecting the conduit, and that's going to be the UTC dive master. You know, letting us know as OICs, you know, what the heck's going on down there and what the recommendations are. That's their ball of wax. But to keep the system in place long term, you will have to anchor to the bottom. Any questions on that? All right, there's your SOM. Now the SOM, it has its own ballast. It has an actual swivel pigtail here, right here. That thing will swivel 360 degrees around the SOM base. All right, and then here's your mooring anchor. Your mooring buoy goes up to the surface, and then your conduits going all the way from the SOM base all the way to the BTU. This is the supply hose from the ship, pigtail, going down to the SOM base. This is what the BTU looks like, beach termination unit. Once again, it's airtight, watertight, and it has ballast. You can't fill it up with water. There's one in Yemen right now that we deployed. Well, we didn't deploy it, probably Fib 1 did. That the Yemenese government actually, instead of putting water in it, they ballasted it down with concrete, and it's still there today. But that's what she looks like. Notice she's got a forklift capability and also a skid. That's why they can drag it up on the beach for rough terrain operations up on the beach. All right, now these are some deployment operational limits. The water depth for the system has got to be at least 35 feet. However, read the tech manuals, you'll find out that the MPS ships require 45 feet. That's a ship limitation. The maximum significant wave height, no greater than 5 feet. The maximum current velocity is a knot and a half. Same thing as A-blacks. Same thing as A-blacks. The maximum wind velocity is 16 knots. Now, bottom conditions, seafloor, you want a 1 to 25 or less. Everybody know what I'm talking about? 1 to 25 scope. And the ideal bottom conditions would be mud, sand, coral bottom. The only unacceptable conditions if it was rocky or strewn bottom. And it's not acceptable for the barge deployment. Here's some inshore requirements from both different types of companies that will be receiving this product. Your Army bulk fuels company requirement is the system must have 150 psi pressure. Now that pressure has got to be from the ship. So during the planning processes in the OPP or pre-deployment, would be talking to the master and talking to the chief engineer in Seattle and make sure he can meet those pressures when the system's rigged. The USMC amphibious assault fuels guys, their requirement's only 125 psi. All right, I hope you can see that good. That is the ship actually listing 33 degrees. 33 degrees to deploy the SOM and the buoy. The SOM base and the SOM single anchor leg board. Very dangerous evolution. All right, the SOM base is 150 feet by 57 feet by 12 foot deep, and it weighs 839 tons. And that's with all the buoys, hose, and anchor chain aboard. And all the series of whole ballast tanks connected to the internal and external pig, allowing the flood of the base under close control and water depths up to 35 to 200 feet. Practical operation restricted limits depth to 190 feet for Navy support divers. Because anything less over 190 feet, you got to start pumping gas to the divers, compressed gas.
Mixed gas.
Or mixed gas, excuse me.
Air limit's 190 feet. Mixed goes 200 plus.
Right.
Significantly changes the support required today. You can dive off a lark
Right.
on air. You need a whole lot more support with mixed gas and chamber support too.
Okay, this is how they're going to actually deploy it from the ship. They're going to use the UB boats, the OUB guys, and they're actually going to rig tow lines, and they're going to help drag it off the ship. And then they're going to position it where the stern is in the current. They're going to pull forward and they're going to deploy their bow anchors to help hold them. Then they're going back in and back down with the current. This guy's going to be pulling ahead this way. Then the UTC guys are going to have the dive boat come over and actually board the SOM and start control sinking this side. And as they control sink that side, and it hits the bottom, and this is relatively shallow jet. Once it hits the bottom, you got to watch that current because it actually flip the entire SOM over. That's why these guys on this side are really pulling hard. They got their anchors out. If it was in deeper water, you control sink it, teeter-totter it all the way down, but you can't let it get too far over or the current will flip it over. That's why I would not want to be a UTC diver on this thing, because they have to ride this thing all the way down to the bottom. And if it does flip over, it can sink those boats too, because it's going to pull them all the way down to the bottom with it, or at least the length of their tow.
So that's jetted into the bottom.
What's that, sir?
So on the previous picture, you had jetting water. So when we do that, it's we're either trying to bury something or get it out. Basically, it clears the mud. So I was curious, where we had the jetting water there, are we actually trying to bury part of it in the seafloor?
No, sir. I'm not really sure why they said jetting complete. But as they're sinking these forward and aft tanks, it's just a controlled settle on the bottom. And it's not anchoring anything, it's ballast, and that's what holds it on the bottom.
But Chief, doesn't it have feet that can kind of grip?
I asked Chief Johnson about that. There are feet, but he really couldn't go into detail to how that was deployed to help position it and hold it to the bottom. To my knowledge, and when I've talked to the instructors about it, it's the ballast itself that holds it fast to the bottom. There's another picture of it. All right, like I was saying, this is kind of like an OPCON thing, waterborne operations. This is all following this on scenario. Now, the OPDS tanker, once it anchors, Command Amphibious Task Force is going to be in charge with the concurrence of the Marine Corps Service Support Group, possibly represented by some element of the Landing Force Support Party ashore. Those guys are going to be fuels guys, which are not called Fuel Service Support Group anymore. They're called Amphibious Assault Fuel System, whatever it's called nowadays. But when tankers brought into the AOR and anchored, and the ship's master, by the ship's master, any problems with anchoring in the tanker area is assigned to be communicated expeditiously to the fuels element commander and the Landing Force Support Party. And selecting the OPDS anchors necessary, the OPDS tanker be maneuvering to make room for the 4-point more. And those are more pre-deployment considerations, but just for an OPCON, where the Commander Amphibious Task Force, and then right to the MBG-2 combo. And then on down our normal NSC chains. Everybody tracking on that? This is what the conduit looks like. It's actually 3 links. Each length of conduit is 1,014 feet. And 3 links off is 3,042 feet. Like I said, they have 9, I didn't say this before, but they do have all the reels on the ship. They have 9 reels. And each one of these links of 3,042 feet will be on each one of those reels. Now the makeup of this hose has 5 to 6 different layers depending on what type of hose it is, and it also has a metal layer, a woven metal layer that kind of acts like wire rope if you were to bend it. So it only has a 40-degree bend angle on it. That's why these reels are super huge on the ship. And that's why only one section can go on one reel, one 3,000-foot section, because it's real hard stuff. The flange connections, female, male, it's a 6-bolt, 6-inch flange, and the torque specifications are 70 foot-pounds per bolt. So it's a lot more robust than what the A-black systems are, because they're just split clamped together. And those torque specifications are only 35 foot-pounds per split clamp. They also do have mooring collars, like Op said, they're going to be anchored to the bottom, so they also have an actual mooring collar that goes around each coupling that can be used as attachment points for anchors when they do anchor to the bottom. Very similar to A-black, but we don't anchor it. All right, here's what we're talking about deployment methods. Now, there's two ship-to-shore methods. You either in the overboarding or under running, and using the float sink method when they actually take the conduit off the ship. All right, they're going to actually be flooding it, each section, from the ship with water. Each time you deploy this stuff, you actually flood and ballast the hose with water. So the lay repair barge will grab this bitter end, start bringing it out, and bringing it on board of the aircraft, and pulling it toward the beach. And as it's coming off, once it stops at that section of 3,000 foot hose, all right, they'll make the connection on the ship and keep discharging the hose. All right, as they're freaking running the water into ballast. And that keeps it down below the water. It keeps it less susceptible to surface conditions. It actually helps the boat keep position so there can be a straight pull off the ship. Or you can use what they call the leapfrog method of deploying from the ship, where the lay repair barge will be kind of like just making the connections, and the UBs will be grabbing the sections and bringing it out and hooking it up on the repair barge, making those connections on the repair barge, and then another set of UBs will bring another section, move up to the next section and make that connection all the way to the beach. And each time it's being flooded from the ship with water. Now the beach out method is the preferred method. And it's kind of the same procedure with the BTU as far as passing that to the beach and getting it all set up with the anchors. But from the beach out method, you got probably almost 1,000 to 2,000 feet of surf zone hose you can work with from the BTU to pass through the surf zone. So what they'll do is the UBs will take these long sections and pass them to the beach using the lark, make that connection with the surf zone hose, all right, and take the actual end cap off that hose, flood it with water up to 200 feet from the end, so it's not too heavy for the guys to be dragging that stuff up the side of the boat, and then hold that position with the lay repair barge, because the lay repair barge has the fair leads and all that stuff on deck to be able to hold the fittings in place. And then they'll bring sections of hose out to the lay repair barge and works from the beach out seaward until they make the connection with the tanker ship. Those are two different types of methods. Like I said, each time they connect that conduit, they'll flood it with water. Once the whole system is deployed, we got a lot of water to push out. So what they'll do from the ship side is they'll actually put a pig in a pig launcher up on deck on the ship, and with air pressure only at 150 psi or 125 psi, whichever the ship can provide, because there's 4 different types of ship, but only one's still here, and that's that's Seattle, and that's over on the west coast. They'll push that pig at 150 psi, and there's actually a discharge valve that's on the BTU on the beach that will discharge that seawater right on the beach until they purge all the line of all the seawater, all the air. And after it's air and after it holds a pressure test, because once you get it pressurized, you want to make sure you're looking at the readings and make sure it's holding pressure and not bleeding air anywhere. As long as it holds that 125 to 150 psi, you should be good to go. If you lose pressure real fast, then you probably got a perforated hose or a bad connection or something like that along the line of the conduit. And those are 2 different methods. Any questions on the 2 different methods? All right, moving right along. Crew requirements. You have one OIC, which will normally be aboard the tanker. And he is coordinating efforts for the deployment of the rig. He's responsible for deployment of the rig with the ship's master. But there's also a fuels officer requirement that's in the op chain. But that can also be from the inshore fuels companies or the marine amphibious assault fuel system guy. Then the BTU requires 15 total personnel. That's 1 POIC. 1 rig captain, 3 tech riggers, 1 signalman, and 8 riggers. Now the signalman is nothing but he's talking. He's talking to the ship, talking to the lay repair barges, and he's pretty much a comms guy. Now the lay repair barge requires 8 personnel. It can be more depending on what type of deployment. It could be 8 to 12 people because you need a lot of riggers to be able to make those connections and run the winches and the deck jewelry to get those pieces connected. So you got a coxswain, you got an engineer, you got a POIC, and then the rest of them are your deck riggers. And the OUB's got a coxswain, engineer, a POIC, and the rest are deck riggers. The dive boat, our ACV2 requirement is only 5. That's a coxswain, an engineer, and 3 deck riggers. The rest of that party on the dive barge is UTC. And pretty much the UCC dive master is pretty much in charge of that boat after that. Now this is just a timeline, what I pretty much just went through about the 4-day requirement and the 7-day requirement, or excuse me, 48-hour requirement, 7-day requirement. Pre-deployment considerations. Just like if you were doing an NPF mission, you're going to have to deploy your slurp. And with this evolution, it's going to be a little different as far as who you send on your slurp. We have to do 2 different types of surveys. We got to do a beach survey, and we also got to do an anchor survey to make sure we got depth of the water, the bottom's good to go. We can facilitate the room to do a 4-point more, to have enough room to deploy the SOM. So, site survey team for that on a slurp would typically be like an SME from us, of course, an ops S2 type guy, probably an S4. Definitely beach party team rep should be there, do site surveys for the beach. UCTs will be heavily involved in slurp because they're going to be doing the hydrographic surveys, not only the surf zone, but also the anchor site itself and the bottom between the anchor site and the beach. And probably if the beach party team or UCT guys don't have that type of gear with them, or probably have to send some engineering aids with some GPS locators, because it's real critical between the anchorage and SOM placement and the BTU, just like it is with ABLATs. You got to make sure that distance is going to be able to reach, because you don't want catenaries in your hose and extra hose out there. You want pretty much a straight line right to the beach. And just if you were doing a mission for MPF, since it's kind of like the salt follow-on, your OPP, they're going to deploy to the Seattle, do all your LTIs on all your craft, with your lay repair barge, OUBs, and your dive boats, with your coxswains and engineers, making sure all that equipment is rigged and ready to go. And your advanced party, you know, like I said before, the advanced party is probably going to be a little bit smaller because you already have the assault following forces there for the beach party team with the dozer decks that have come from us. But those will probably be some of the elements of the advanced party to set up the beach site for the BTU. To be coordinated with the land enforcement support party also. Any questions on that? All right. Now let me show you what the future of OPDS is going to be. About a 7-minute video. Great, I know this sound. It's awesome. Thanks.
Source of fuel, For more than 20 years, combat commanders have relied on the Offshore Petroleum Discharge System, OPDS, a sea-based system that rapidly delivers large volumes of refined petroleum from offshore tankers to shore-based military fuel storage facilities.
You've probably seen this guy before. You've been in NPF staff planner. Here in a minute.
The legacy OPDS system, when it was developed, was state-of-the-art. Since then, warfighters have developed increased requirements, increased capabilities that they need for the fuel system. And the old system was not capable due to the limitations of the system providing that. Limitations as far as volume of fuel, distance pumping offshore, and that sort of thing.
Realizing that warfighter needs had outgrown the existing system, Military Sea Lift Command, together with the Defense Logistics Agency's Defense Energy Support Center, Warfighting Commands, and other stakeholding commands, worked to design and construct a new system to meet these new requirements. The centerpiece of the next generation OPDS is the newly constructed motor vessel Vice Admiral K.R. Wheeler. Designed and built by SCWS Offshore, a Louisiana-based shipbuilder and operator with nearly half a century of experience servicing oil firms operating in the Gulf of Mexico, the Wheeler employs state-of-the-art commercial off-the-shelf technology. Going to the private sector for the new OPDS tanker made sense because the vessel had to be rugged and reliable, much like the offshore vessels operated by the commercial oil industry. These are vessels that can operate in the most severe weather conditions and whose failure can literally cost industry users millions of dollars per day. The 21st century OPDS offers several improvements over the legacy system. It is deployed and operated with approximately 30 civilian merchant mariners and mission specialists, a crew reduction of more than 80%. The system can pump 1.7 million gallons of fuel per 20-hour day, a 40% increase over the legacy system. And it can deliver fuel from up to 8 miles offshore, twice the distance of the old OPDS, on all sea bottom conditions in significantly higher sea states, winds, and currents. The new system can also be deployed and operated in more challenging environmental conditions.
The flotation buoys that are used in the system are designed for beach conditions, underwater conditions that are perhaps rock or coral or something that might damage the pipe. Although the system has armored pipe that's used in that case as well, the flotation collars that we put on the pipe enable the pipe to float on the surface, which makes it easier to tow to shore.
In addition to the Wheeler, which measures 348 feet long with a 70-foot beam, other key components of the new OPDS are an accompanying tender vessel, the Fast Tempo, measuring 165 feet long with a 30-foot beam, 2 LARC 15s, lighter amphibious resupply cargo vehicles that deploy the OPDS Conduit and Beach Terminal Unit, BTU, and can also support other beach preparations. And 1 8-meter and 2 12-meter workboats, which can assist as needed in transferring personnel, parts, or other materiel. Another key component of the new OPDS vessel is its dynamic positioning system, DPS. With the aid of the OPDS tender, the DPS enables the vessel to maintain its own position and that of the fuel tanker.
The dynamic positioning system makes this ship really unique. What it does is it will hold the ship at a geographic position on the sea surface within about 2 meters radius in any direction. So we don't have to anchor it. It makes the whole pipe deployment operation a lot safer and a lot faster.
The Wheeler is also a multi-purpose vessel with a towing winch that can tow a large tanker or cargo ship in distress, and fire monitors for assisting in firefighting efforts afloat and ashore as needed. Prior to being accepted by MSC, the OPDS successfully completed rigorous testing and evaluation.
In any contract that the government puts forward, the system has to be proven before we can accept it. This is a test, an acceptance trial that will prove to us the system operates in accordance with the contract specifications, give us the amount of fuel oil every minute that we have asked for, supply pipe along 8 miles of sea bottom up to a BTU and supply fuel to the combat unit on the shore. And as soon as they meet these specifications, we can accept the vessel as a Navy asset.
The new OPDS was designed to meet strict technical requirements, and these requirements were tested to the maximum extent possible prior to government acceptance of the system. First, the system's flexible conduit must be deployed in 48 hours or less in 40-knot winds in seas with 6-foot waves and a 3-knot current, and in tides with a range of 13 to 20 feet. Next, once the pipe is deployed, the pipe system must be able to deliver product in winds of 42 knots, waves of up to 12 feet, and currents of up to 5 knots, with a tidal range of up to 20 feet. Finally, after pumping operations are complete, the pipeline must be retrieved for reuse within 72 hours. With the testing equipment secure, the OPDS vessels are ready for their next mission.
I think that MSC and DESC are providing a capability that the warfighters need. I think that the system is going to provide them a quantum leap in what they have currently available. And once we get out there, I think we're going to be testing the system a lot and show the people that this is going to be a very good system for the Army and the Marine Corps and the Air Force.
Since 1993, Military Sea Lift Command has worked with commercial industry and its military sponsors to develop a mobile system that enables the military to rapidly pump fuel ashore over long distances in the most austere environmental conditions. The next generation OPDS fulfills these requirements. The new OPDS is flexible, it reacts quickly, and it has enormous capabilities. OPDS, fulfilling the operational needs of 21st century commanders.
All right, cool stuff, huh? That's the future. It's already here. They're already building another ship.